Assalamu alaikum dear students. I am Shahid Akram, Subject Specialist Chemistry at BPS Sahiwal. You are studying Chemistry FSC Class 12, Chapter number 11, Alcohols, Phenols and Ethers. I hope you are taking regular classes of DPS Digital Media and continue your studies very well. Let me start our today's topic. This topic is related to reactions of alcohols and their identifications. Let me start today's topic. Dear students, you are studying chapter number 11, Alcohols, Phenols and Ethers. Today's third lecture of chapter number 11. This is lecture number 29 and our today's topic is 11.3. After the lesson, you will be able to explain different reactions of alcohols, identification of different types of alcohols by Lucas test, and some uses of alcohols, especially methanol and ethanol. Let me proceed forward. Before going to details of our today's topic, let me summarize what we have studied previously in lecture number 11.1 and 11.2. Students, we know alcohols are organic compounds which contain OH group as a functional group with alkyl radicals. They are called as alcohols. Different examples of alcohols contain some alkyl radical with OH group as a functional group. They are represented by a general formula ROH, where R is an alkyl group and OH will be the functional group accompanied with some alkyl group. For example, alkyl group may be CH3, which is methyl, CH3, CH2, it is called as ethyl, C6H5, it is called as phenyl group. Let me see different examples of alcohols. Methyl alcohol or methanol, CH3OH, where CH3 group is methyl group and OH group is functional group, which will be accompanied with alkyl group. Ethyl alcohol, also known as ethanol, which contain ethyl group with OH functional group. Propyl alcohol, CH3, CH2, CH2, OH. So this is alcohol containing one carbon atom known as methanol, alcohol with two carbon atoms known as ethanol, alcohol with three carbon atoms known as propanol. Starting from propanol, there will be some isomers called 1-propanol or 2-propanol. We have already discussed the isomerism of alcohols in lecture number 11.1 of nomenclature of alcohols. Alcohols may contain one OH group as a functional group called as monohydrate alcohols like butanol containing 4 carbon atoms. It is the OH group present at first carbon atom, so it is called as 1-butanol, and if the OH group is present on second carbon atom, it is called as 2-butanol. It is primary alcohol, it is secondary alcohol. There are some examples of alcohols which contain more than one OH group, like 1,2-ethane diol, commonly called as glycol, and 1,2,3-propane triol, commonly called as glycerol. These different alcohols, they have only one hydroxyl group or OH group as a functional group, and these are the alcohols which contain more than one OH group. Like here there are 2 OH groups, and here there are 3 OH groups. Alcohols containing one OH group are called as monohydric alcohols, and alcohols containing more than one OH group are called as polyhydric alcohols. So depending upon number of OH group, alcohol are classified into monohydric alcohols and polyhydric alcohols. Let me have some examples of these alcohols. Methanol, ethanol, propanol, butanol and pentanol. They are the examples of monohydric alcohols because there is only one OH group in alcohols. If there are more than one OH groups in alcohol, they are called as polyhydric alcohols. Like glycol contain 2 OH group at 2 adjacent carbon atoms. It is called as 1,2-ethane diol. Alcohols contain 2 OH group are called as dihydric alcohols, and if these 2 alcohols are present on 2 adjacent carbon atoms, they are called as glycols. Similarly, there may be 3 OH groups on 3 adjacent carbon atoms. They will be called as glycerol. This is the example of 1,2,3 propane triol. Monohydric alcohols, they are further classified into primary, secondary and tertiary alcohol depending upon the carbon on which it is attached. For example, this is a primary alcohol because OH group is present on the first carbon atom, which is primary carbon. This is the example of secondary alcohol because the OH group is present on the secondary carbon. This is the example of tertiary alcohol because the OH group is present on the tertiary carbon. The classification of primary, secondary and tertiary carbon atoms we have already discussed in the nomenclature of alcohols. We have already discussed the nomenclature in lecture 11.1 and preparation of alcohols and its physical properties of alcohols in the lecture topic 11.2. Here today we will start from reactions of alcohols. Alcohols react with other reagents in 2 different ways. Number 1, reactions in which carbon-oxygen bond of alcohol will be broken, and number 2, reactions in which oxygen-hydrogen bond will be broken. Which bond will break depends upon the nature of the attacking reagent. Alcohol contain OH group. The attacking substance that may be nucleophile or electrophile. The bond carbon-oxygen bond or oxygen-hydrogen bond will break up by the attack of nucleophile or electrophile. If a nucleophile attack on the alcohol, the carbon-oxygen bond will break, and if an electrophile attack on the alcohol, the oxygen-hydrogen bond of alcohol will be break. Let me see examples of some attack of nucleophile on alcohol. This is ethanol, ethyl alcohol. When nucleophile will attack, nucleophile means nucleus loving species, it will attack on the carbon atom. So the carbon-oxygen bond will break up because nucleophile will attack on this carbon atom. It requires the nucleophile site. Carbon have partial positive charge, so nucleophile will attack on this carbon atom. As a result, carbon-oxygen bond will break up. So bond will break up from this carbon and oxygen position. So the product produced will be ethyl positive ion and OH negative ion. The order of reactivity of alcohols when carbon-oxygen bond break up will be following. Tertiary alcohol will be the most reactive one, then secondary alcohols, and then primary alcohols. It means when nucleophile is the attacking substance, tertiary alcohol will be the most reactive one and primary alcohol will be the least reactive one. Or you can say primary alcohol will be the stable alcohols for the attack of nucleophile. On the other side, when electrophile attack on the alcohol, oxygen-hydrogen bond will break up. This is the formula of alcohol. Electrophile means electron-loving species. It will attack on the oxygen of the alcohol group to pick up electron. So the bond between oxygen and hydrogen will break up, and as a result, ethoxide negative ion plus H positive ion will be produced. The order of reactivity of alcohols when electrophile attack on the alcohol and oxygen-hydrogen bond will break up, the order will be opposite to the reaction in which nucleophile attack on the alcohols. Here primary alcohols will be reactive and tertiary alcohol will be the least reactive or stable. Among primary alcohols, methanol will be the most reactive one and then all other primary alcohols. Secondary alcohol will be least and then tertiary alcohol will be the least reactive and which are stable alcohols. Let me have some examples of reactions in which carbon-oxygen bond is broken. The first one is ethanol on reaction with thionyl chloride SOCl2. This reaction will take up in presence of pyridine as a solvent. As carbon-oxygen bond will break up, so OH will be removed and nucleophile Cl will be replaced. So the product produced will be ethyl chloride. The oxygen will combine with SO group to produce sulfur dioxide gas. Hydrogen will combine with remaining chlorine atom to produce HCl gas. Number 2, ethanol or ethyl alcohol on reaction with HCl in presence of zinc chloride. Concentrated HCl in presence of anhydrous zinc chloride, commonly called as Lucas reagent. Later we will see that how alcohols can be identified by using this Lucas reagent. Here we are discussing the reaction of attack of nucleophile. Here chloride from HCl is acting as a nucleophile. So carbon-oxygen bond will break up, Cl will replace with OH producing ethyl chloride and OH will combine with H to produce water molecule. Number 3, ethanol or ethyl alcohol or reaction with ammonia in presence of thorium oxide as a catalyst. From ammonia NH2, amino group is a nucleophile. It will replace the OH group from alcohol, breaking the carbon-oxygen bond, and then OH group will be replaced with NH2 group producing ethyl amine plus water is the product. On the other hand, reactions involving the cleavage of oxygen-hydrogen bond when electrophile is the attacking species. Number 1 is ethanol or ethyl alcohol on reaction with some electrophile, electron-loving species like sodium metal. The oxygen-hydrogen bond will break up. As a result, hydrogen will be replaced with one sodium atom, producing salt of alcohol called as sodium ethoxide. This is ethoxide ion and this is sodium, so it is called as sodium ethoxide. Two hydrogen atoms will combine to produce hydrogen gas. These type of reactions are also known as salt formation reactions of alcohols. Number 2, ethyl alcohol on reaction with Grignard reagent, methyl magnesium iodide. It is a well-known Grignard reagent. You are very familiar with the reactions of Grignard reagent in chapter number 10. This is the same example that Grignard reagent will react with alcohol producing alkane. So oxygen-hydrogen bond will break up. this hydrogen will combine with CH3 group from Grignard reagent producing methane. The alkoxide group will combine with remaining species of Grignard reagent producing magnesium ethoxy iodide. Ethoxide group will combine with magnesium producing magnesium ethoxy iodide. Number 3, ethyl alcohol on reaction with acetic acid in presence of concentrated sulfuric acid or any mineral acid producing its salt ethyl acetate. These type of reactions are also known as esterification reactions. Esters are produced by reacting organic compound alcohols with organic acids producing some different salts called as esters. Here we are using ethyl alcohol and acetic acid or ethanoic acid producing ethyl acetate. Ethyl group come from alcohol and acetate group come from acetic acid producing ethyl acetate, well known ester. Plus water molecules are also produced. Some other reactions of alcohols are following, which are oxidation, dehydration, and some reactions of alcohol with phosphorus halides. Let me see the first one, oxidation reaction. Oxidation of alcohols will take place in the presence of some oxidizing agents. Alcohols on oxidation will convert into aldehydes and ketones. The best oxidizing agent for this purpose is acid dichromate. Commonly used acid are sulfuric acid, and dichromates may be sodium dichromate or potassium dichromate. So acid dichromate will be sodium or potassium dichromate in presence of acid like H2SO4. Primary alcohols on oxidation with acid dichromate produces aldehydes, and secondary alcohols upon oxidation with some oxidizing agent will produce ketones. So primary alcohols on oxidation produce aldehydes, and secondary alcohols on oxidation will produce ketones. This is an example of primary alcohol, ethyl alcohol. On oxidation, it will produce aldehyde, ethanol or acetaldehyde. 2 carbon atom alcohol is called as ethanol, and 2 carbon atom aldehyde is called as ethanol, commonly called as acetaldehyde. Oxidizing agent will produce atomic oxygen, which will oxidize the respective alcohol. Let me take an example of secondary alcohol. Isopropyl alcohol, or IUPAC name 2-propanol. This is a secondary alcohol. Upon oxidation by acid dichromate, it will oxidize to produce ketone. 3 carbon atom alcohol will produce 3 carbon atom ketone propanone, commonly known as acetone. The secondary carbon atom will oxidize to produce ketonic group, and here the primary carbon atom will oxidize to produce aldehydic group. Tertiary alcohols, they are not oxidized by some oxidizing agents. They are resistant to oxidation. So in the presence of acid dichromate, they undergo elimination reactions producing alkenes. They will not be oxidized, rather they will take place elimination reactions, and the product produced will be alkene. Here is an example of tertiary alcohol. This is tertiary butyl alcohol. IUPAC name is 2-methyl 2-propanol, because the carbon atom on which functional group is present, it is tertiary carbon, because there are 3 carbon atoms directly attached with this carbon atom. At carbon number 2, there is a methyl group as a branch, and At carbon number 2, there is OH group, so it is called as 2-methyl 2-propanol. You are already familiar with the nomenclature of alcohols, which we have discussed in topic 11.1. This tertiary alcohol on oxidation with acid dichromate, oxidation will not take place, rather elimination will take place. The OH group from this carbon atom will be eliminated, and hydrogen atom from these 3 carbon atoms which are attached with this tertiary carbon, hydrogen will be removed, then hydrogen will combine with OH to produce water. If hydrogen is removed from this carbon atom, double bond will take place at this position. If hydrogen is removed from this carbon atom, then double bond will take place from this position. Here I have taken the OH group from this carbon and hydrogen from this carbon. So double bond will be produced between these 2 carbon atoms, producing alkene. The product produced is called as 2-methyl propene. The second reaction is dehydration. Dehydration means removal of water. Alcohols on dehydration produce alkenes or ether by using some dehydrating agent. Sulfuric acid, alumina, phosphorus pentoxide, they are well known dehydrating agent. Here we are using concentrated sulfuric acid as a well known dehydrating agent. Alcohols react with concentrated sulfuric acid and give different products at different temperatures, like ethanol ethyl alcohol on reaction with concentrated sulfuric acid at 180 degrees Celsius, product produced will be ethene, and if the reaction will take place at 140 degrees Celsius, the product produced will be ether. At 180 degrees Celsius, water will be removed to produce ethene gas, but when the reaction will take place at 140 degrees Celsius, 2 moles of ethyl alcohol, by the elimination of water molecule, these 2 alkyl group will combine to produce ether, diethyl ether. The next reaction of alcohols with phosphorus halides, PCl3 and PCl5. Alcohols on reaction with phosphorus trihalide, 3 moles of alcohol will be required. Replacing these 3 OH group with nucleophile halogen from phosphorus trihalide, producing ethyl halide. Here we are using chlorine as a halogen, phosphorus trihalide producing ethyl chloride. Phosphorus, 3 hydrogen atom and 3 oxygen atom will combine to produce phosphorus acid. Ethanol on reaction with phosphorus pentahalide, OH group will be replaced with 1 chlorine group producing ethyl chloride, 1 phosphorus, 1 oxygen and 3 chlorine atom will combine to produce phosphorus oxychloride, and remaining hydrogen atom will combine with 1 chlorine atom producing HCl. Now, after the completion of reactions of alcohols, there is a test which is used for distinction between primary, secondary and tertiary alcohols. By using Lucas test, we are able to identify between different alcohols which may be primary, secondary or tertiary alcohols. Primary, secondary and tertiary alcohols, they can be identified and distinguished by reacting them with Lucas reagent. And what is Lucas reagent? It is the solution of concentrated hydrochloric acid in presence of anhydrous zinc chloride. So alcohols which are given, they will be reacted with Lucas reagent, and formation of product will indicate the nature of the primary, secondary and tertiary alcohols. By reacting alcohol with Lucas reagent, following observation will be produced. An oily layer of alkyl halide separate out in these reactions. Alcohols are aqueous like water, and when they react with Lucas reagent, they convert into alkyl halides. Alkyl halides are oily liquids, so we can easily identify between aqueous layer and oily layer. When given alcohol is reacted with Lucas reagent, if the alcohol is tertiary, then tertiary alcohol form an oily layer immediately when the reaction takes place. If the alcohol is secondary, the secondary alcohol form an oily layer in 5 to 10 minutes by reacting the substances. But primary alcohols, they form oily layer only upon heating. Let me take some examples of these different types of alcohols. This is a tertiary alcohol because the carbon atom is tertiary, attached with 3 different alkyl groups on this carbon atom on reaction with Lucas reagent. Lucas reagent is concentrated HCl in presence of anhydrous zinc chloride. The reaction will take place immediately and the oily layer of tertiary alkyl chloride will be produced immediately. Secondary alcohol on reaction with Lucas reagent produce secondary alkyl halide. The oily layer of this alkyl halide will produce about in 5 to 10 minutes. We will wait for 5 to 10 minutes for the formation of oily layer. But when primary alcohol is reacted with Lucas reagent, like this is a primary alcohol on reaction with Lucas reagent, oily layer of alkyl chloride will produce only upon heating. It means the reaction will not take place at ordinary temperature. If the given alcohol is primary, the formation of alkyl chloride will produce only upon heating. Let me explain the demonstration of Lucas test with an experiment. For identification of different alcohols, we have to use some Lucas reagent. And what is Lucas reagent? It is concentrated HCl in presence of anhydrous zinc chloride. Here are different 3 test tubes containing different alcohols, primary, secondary and tertiary alcohols. When we add Lucas reagent to a test tube, if the formation of oily layer of alkyl halide produced immediately, we can say the alcohol is tertiary. And upon the addition of Lucas reagent to another test tube containing some alcohol, the formation of alkyl halide oily layer will produce in 5 to 10 minutes, then the alcohol is secondary alcohol. And if we add Lucas reagent to an alcohol and the formation of oily layer do not take place even after waiting 5 to 10 minutes, then we can say the alcohol may be primary, and upon heating the formation of alkyl halide will produce and we can say the alcohol is primary alcohol. Now we will move toward an identification test between methyl alcohol and ethyl alcohol, distinction between methanol and ethanol. Methanol and ethanol can easily be identified by using iodoform test. Ethanol gives iodoform with iodine in presence of sodium hydroxide. The observation will take place by using this iodoform test. The yellow crystals of iodoform will indicate that the given alcohol is ethanol. It means if the given alcohol is ethanol on addition of iodine in presence of sodium hydroxide, yellow crystals of iodoform will produce that show the given alcohol is ethanol. Methanol do not give this iodoform test. Reactions of ethanol and methanol with iodoform. Ethanol react with iodine in presence of alkali sodium hydroxide. Reaction will take place producing yellow crystals of iodoform CHI3, also known as triiodomethane, sodium formate plus sodium iodide are produced. These two salts will be dissolved in water in the aqueous layer, and the yellow crystals of iodoform will be separated out. Ethanol do not react with iodine in presence of sodium hydroxide, so no yellow precipitates will be formed. So we can say that if we want to identify between methanol and ethanol, we can use iodoform test. Let me explain the iodoform test with some demonstration experiment. Here is an experiment. The apparatus required for iodoform test are following. We have to use hot water bath for heating the given reaction of ethanol or methanol with iodine in presence of sodium hydroxide. Here in this test tube there is 2 molar sodium hydroxide solution, and here is 10% iodine solution in potassium iodide. In this test tube there are some alcohols. We have to identify ethanol. Let me take ethanol in a test tube. About 2 to 3 cubic centimeter of ethanol will be added in a dry test tube. Approximately 1 to 2 cubic centimeter of ethanol is sufficient for identification test. Now add iodine solution in this ethanol solution. About 1 to 2 cubic centimeter of iodine solution will also be added into the ethanol solution. So now in this tube there is ethanol and aqueous iodine solution. Approximately equal volumes of iodine will be added to ethanol solution. Now we will add sodium hydroxide solution to this mixture of ethanol and aqueous iodine. Sodium hydroxide solution will be added to the mixture of ethanol and aqueous iodine slowly, dropwise, with constant shaking. Sodium hydroxide solution will be added to the solution dropwise, and shaking will continue till the removal of brown color of iodine. Shake well so that the reactant may combine with each other. Shake continuously. Add more amount of sodium hydroxide in the test tube so that reaction may completely take place. Continue the addition of sodium hydroxide until the reddish brown color of iodine is removed. The reaction will continue until brown color just disappear. When the brown color of iodine disappears, add this test tube into hot water bath, because the formation of yellow crystals or precipitates of triiodomethane or iodoform will produce at high temperature. After some time, you can see that yellow precipitates of triiodomethane or iodoform, they are produced in the test tube with some antiseptic smell. So you will be clear that how ethanol and methanol can be identified. This test is only given by ethanol. Methanol do not give this test. Now move toward some uses of alcohols. Here are some of the broad uses of alcohols. They are used for manufacturing of perfumes. They are used as solvents for the manufacturing of antiseptics. In some countries they are also used as fuels and also used as drinks. Some more uses of alcohols: they are used as disinfectants, as solvents, as liquor, high efficiency fuels. They are also used for the manufacturing of some other compounds, in manufacturing of fungicides, which are a group of pesticides, formation of some cosmetics. Ethanol is especially used to make vinegar, and they are also used for the manufacturing of plastics. But here we will focus on the use of methanol and methanol. Methanol, which is produced by some different sources: natural gas, a coal or heavy hydrocarbon gasification, waste carbon dioxide. But this methanol is used for production of biodiesel, some chemicals, gasoline, DMEs, and some neat alcohol fuels. Ethanol is used for fuel for vehicles, for preparation of paints, varnish, perfumeries, alcoholic drinks, and it is also oxidized to produce ethanoic acid, which is further used for preserving foods and making some flavoring agent esters. These are some broad uses of alcohols, especially methanol and ethanols. But we will focus on the uses of alcohols which are represented in our books. Methanol, that is used as a solvent for fats, oils, paints, and varnish. Methanol is also used as an antifreeze in the radiators of automobiles. We are very familiar that radiators, they use some coolant materials called as antifreeze, so that radiators may not boil over or water may not freeze in the radiators. Methanol is also used as a denaturing agent for alcohols. It is used for denaturing of alcohols. On the other hand, ethanol, that is used as a solvent for making some other chemicals. It is used as a drink in some countries. It is used as a fuel in some countries, like Brazil is one of the countries which use ethyl alcohol as a fuel in automobiles. Ethyl alcohol is also used in pharmaceutical preparations, making some medicines like homeopathic medicines. They use ethanol as a solvent for different medicines. Ethanol is also used as a preservative for preserving some biological specimens. Ethanol is also used as a sterilizing agent for surgical instruments. It is also used for making alcoholic pads. Now, the questions related to this topic, exercise questions. Question number 4. Statement of the question is: what are alcohols? How are they classified? How will you distinguish between primary, secondary, and tertiary alcohols? Question number 8. How does ethyl alcohol react with the following reagents: concentrated sulfuric acid, sodium metal, phosphorus pentachloride, ethanoic acid, and thionyl chloride. Question number 10. How will you distinguish between an alcohol and a phenol? Number 2. An alcohol and an ether. Number 3. Methanol and ethanol. Number 4. A tertiary alcohol and a primary alcohol. Number 5. 1 propanol and 2 propanol. For question number 4, in today's lesson, we have also discussed different types of alcohols, but in lecture number 11.1, you discussed the alcohols in details, their classification. In today's lesson, we have used a test, Lucas test, for identification between primary, secondary and tertiary alcohols. So you have already discussed this question in details. Let me continue with question number 8. Question number 8 said that how does ethyl alcohol react with the following reagents? Number 1. Ethyl alcohol react with sulfuric acid, producing different products at different temperatures. Ethyl alcohol on reaction with sulfuric acid at 180 degrees Celsius, it will produce ethene, and at 140 degrees Celsius, it will produce ether, diethyl ether. Number 2, reaction of ethyl alcohol with sodium metal, it is a salt formation reaction. Ethyl alcohol on reaction with sodium, it produces sodium ethoxide and hydrogen gas will be eliminated. Reaction of ethanol with phosphorus pentachloride. Ethyl alcohol on reaction with phosphorus pentachloride, it will produce ethyl chloride, phosphorus oxychloride and HCl will be produced. In today's lesson, we have discussed the reaction of ethanol with different phosphorus halide, but here in this question, reaction of ethyl alcohol is asked to react with phosphorus pentachloride. Number 4, reaction of ethyl alcohol with acetic acid. Ethanol or ethyl alcohol on reaction with acetic acid produce ethyl acetate. It is an ester used as a flavoring agent. Number 5, reaction of ethyl alcohol with thionyl chloride. This reaction will take place in presence of pyridine, producing ethyl chloride, and sulfur dioxide gas will be eliminated with formation of HCl. Now question number 10. How we can distinguish between different organic compounds? The first one is an alcohol and a phenol. How we can distinguish between the given alcohol and phenol? Given alcohol and phenol can be identified by using a Lucas test. Alcohol will give a positive Lucas test, while phenol do not give Lucas test. Alcohol forms oily layer by reacting with Lucas reagent, mean in reaction with concentrated HCl in presence of anhydrous zinc halide. If the given compound is alcohol, it will react with zinc halide, it will produce oily layer of alkyl halide. If the alcohol is tertiary, oily layer will form immediately. If the alcohol is secondary, oily layer will form in 5 to 10 minutes. But if the alcohol is primary, the oily layer will form on heating. Phenol do not give this Lucas test. So no product will be produced when phenol react with Lucas reagent. Number 2, distinguish between alcohol and ether. We can identify alcohol and ether by Lucas test. Alcohol will form oily layer by reacting with concentrated HCl in presence of anhydrous zinc chloride, while ether do not give this Lucas test. Ether will not give any product on reaction with Lucas reagent. Number 3, distinguish between methanol and ethanol. In today's lecture we have discussed in detail that methanol and ethanol can be identified by iodoform test. Ethanol give positive iodoform test. Ethanol forms yellow colored crystals of iodoform while reacting with iodine in presence of sodium hydroxide. Ethanol on reaction with iodine in presence of sodium hydroxide and alkali, it will produce yellow crystals of triiodomethane or iodoform, which shows that given alcohol is ethanol. Methanol do not give iodoform test, so no yellow precipitates will be formed even on heating. Number 4, distinction between tertiary alcohol and primary alcohol. This can be easily identified by using Lucas test. Tertiary alcohols on reacting with Lucas reagent forms oily layer immediately when reacting with concentrated HCl in presence of zinc halide. So tertiary alcohol on reaction with HCl in presence of zinc chloride, it will produce oily layer immediately. While the primary alcohol, they give also Lucas test but forms oily layer only on heating. They will give oily layer of alkyl halide only on heating. Number 5, identification between 1-propanol, which is a primary alcohol, and 2-propanol, which is a secondary alcohol. So we can use Lucas test for differentiation. 2-propanol, which is a secondary alcohol, give positive Lucas test. It will form oily layer in 5 to 10 minutes while reacting with concentrated HCl in presence of zinc halide. Mean that secondary alcohol 2-propanol will react with Lucas reagent and form oily layer in 5 to 10 minutes. While 1-propanol, which is a primary alcohol, it also gave positive Lucas test, but the oily layer of propyl chloride will give on heating. So if the oily layer form in 5 to 10 minutes, then it is 2-propanol, and if oily layer is produced on heating, then the given alcohol will be 1-propanol. So this is all over today's topic. What we have discussed today, let me summarize. We have discussed alcohols, reactions of alcohols. The reactions of alcohols, they are categorized into 2 types. The first type, in which some nucleophile or electrophile will attack. When nucleophile attack, the breakage of carbon-oxygen bond will take place. And when some electrophile will attack, the bond between oxygen and hydrogen in the alcohol will break up. There are some other reactions of alcohol which we have discussed, which are oxidation. Alcohol will oxidize by using some oxidizing agent like acid dichromate. They produce aldehydes and ketones, but tertiary alcohol will not oxidize. They give elimination reaction forming alkenes. Alcohols on dehydration produce alkenes on reaction with some dehydrating agent like sulfuric acid. Alcohol produce alkene and ethers at different temperatures. Alcohols also give different products by reacting with phosphorus trihalide and phosphorus pentahalide. And then we identified the primary, secondary and tertiary alcohols by Lucas test. Primary, secondary and tertiary alcohols on reacting with Lucas test, they produce oily layer of alkyl halide, which shows the identification of primary, secondary and tertiary alcohols. After it, We differentiate between methanol and ethanol by using iodoform test. Ethanol gives positive iodoform test, forming yellow crystals of iodoform, while methanol do not give this test. And at the end of the lesson, we have discussed some uses of alcohols, especially of methanol and ethanol. So here is assignment for today's topic. Question number 1. Give 2 methods for the preparation of alkyl halide from alcohols. Question number 2. Why tertiary alcohols cannot be oxidized? Question number 3. How alcohols can be used to prepare esters? Explain with an example. I hope you can easily give the answers of these different questions. I have discussed these different questions at various parts of the lesson. So if there is any problem, you can revise today's lesson, then you can answer these different questions. So this is all over today's lecture. From my side, thank you very much. Take care of yourself. Inshallah, next time we will continue with some other topic. So till next time, Allah Hafiz.